Greetings and welcome to the 80 Level Roundtable podcast. In each episode, host Kirill Tokarev invites video game industry leaders to talk about the world of game development. No topic is off limits as long as it relates to video game development. New episodes are in the works, so remember to follow us or subscribe and share with someone you know will also enjoy the podcast.
Hello, and welcome to the 80 Level Roundtable, where we discuss the latest tech in games and 3D. And today we have with us Josh Hope and Jaime Martinez, who are gonna talk a little bit about the cool new thing. I mean, not that new, but still cool, 3D printing. So guys, before we start, could you do a little introduction, tell a bit about yourself and your company?
Sure. I'm Josh Hope. I'm a senior manager for 3D printing and engineering projects for Mimaki USA.
And I'm Jaime Martinez. I'm the applications specialist, and basically I'm in charge of all the printing applications, finishing, customer questions about the product, and also working with software.
So how long have you guys been doing this, and how long is like Mimaki on this market and of 3D print? Because I know that the company has a very long history in printing in general. So if you could give us like a little intro, how did we get into this new emerging tech? That would be nice.
Sure. So yeah, Mimaki's been around since 1975 in the traditional 2D inkjet and cutting plotters, things like that. But we've been dealing with 3D printing just for the last few years. The 3D UJ553, which is our full color 3D printer, we got our first one just at the end of 2018. And that machine, since then, we've added a couple dozen, I think, at this point in the United States. But yeah, we're traditionally a 2D printing company, and I think that's kind of been our to our benefit, because we're able to use our years of expertise in color matching and fine detail and things like that, and bring that to the 3D market.
So what is the situation with like 3D printing in United States? So I know you started this like in 2018, but from like a very high level general perspective, who uses this kind of equipment? And what are like the main reasons for them to use it? Right? Where can we see that, like the products that are being 3D printed?
So right now, there's some customers that we can talk specifically about, and other customers that we can sort of only generalize because they don't want to.
We can do like a general thing. It doesn't have to be like a specific company.
So a lot of prototyping. There's a lot of in the toy market, in the industrial printing market, in consumer electronics. There are people that are using our machine to not only when you're designing something, to be able to print it out and hold in your hand and see what color it's going to be and what's the texture going to feel like, and those kinds of things. It really makes a big difference. So we've got people, as I said, that are doing prototyping. We've got other customers that are using it to have a printed figure. So if they're going to, let's say they're going to a venture capital meeting, or they're trying to raise funding for a cartoon or for a line of toys, if they can print out that character and it's being passed around the table and people are holding it in their hand and seeing the vibrant colors and able to interact with it a little bit, that just brings a whole level of understanding to the story that they're trying to tell.
Yeah, it makes total sense. I might see like huge advantages in that. So one of the things that kind of strikes our community most about the presentations that you guys did is basically the quality of the print. So from my perspective, it's not like a big 3D user and so on, but when I first saw and kind of like got into 3D printing, it was very primitive. Like at that point, it would be like, I don't know, some very primitive, plasticky kind of shaped things. Not a lot going on there. I wouldn't imagine that somebody would be able to, 3D print something as intricate and some people are create with ZBrush. So just for like a general knowledge, so what were like the biggest advances in this tech in the last like maybe 5-6 years? And what helped us kind of get into the situation right now where we have this amazing quality coming into like a very, I wouldn't say affordable, but equipment that you can potentially purchase and use?
I think so. I'll answer a little bit of this, and I'll hand it to Jaime to answer some as well. I think from a material standpoint, there's the drive for new and unique materials for strength, for the ability to have that fine detail or color. That's been really, really big, right? So when people think of 3D printing, in the most part, they think about the fused filaments, where you've got a spool of plastic material and you're melting it and kind of squeezing it out like a hot glue gun, and you're very limited in what you can do with that. But now we're jetting fine little droplets of photopolymer resins, or in some cases metal, or all these different materials, and it just opens up a huge new world of products and things like that. I'll let Jaime talk about maybe the software that's changed as well.
Yeah, I think it's one of the I guess that the biggest industry differentiators of our equipment is the wide color gamut. So color printing has been around for many years. It was mostly sandstone or like paper-based models. And now we have the multi-jet technology, inkjet technology, and at this point we actually can have that same color capability that a commercial printer has, a standard 2D printer into a 3D print. So it was that's, I guess, the groundbreaking part. Now you can talk about color accuracy, color matching, which it was not possible. You could get an approximate color with a different product. With our product, you can actually talk about color accuracy and matching. So that is pretty exciting for the artists, because now they don't feel limited when they're developing their 3D printed pieces. And now you can talk about not only about geometry and complexity, but also you can talk about color.
Yeah, I think probably the color accuracy is one of the biggest things that's kind of struck me most about these models, because if you're thinking about doing some kind of production, even like it's a very small scale, like if you're building your own model and eventually you do want to kind of sell it to like your fans or whatever, maybe put it in a store somewhere, you do need to make sure that it looks perfect. And I think in the majority of cases, before we kind of got to this level as we have right now, a lot of our users, they were using outsourcing companies from all over, where they couldn't actually get stable results, let's put it this way, right? Because especially with the color matching, it was all over the place. And in some cases, you can see this in like some older stuff that was printed and produced. So it's really nice to see kind of that we finally hit that threshold where it's as if you can basically print what you imagined when you had it like in your render, like on a screen. So I think that's a huge advantage of this kind of tech. So guys, before we go into like more detail, there is obviously a question about how affordable this equipment is and how can you actually purchase it. So as far as I understand, it's mostly for like a bigger enterprise, right? And if you have a company that kind of specializes in this field, it makes sense to buy it. So it's not technically a product for like an individual.
Yeah, I think that's a fair way to say it. It was the 3D UJ 553 was designed as an industrial manufacturing piece of equipment. It's U.S. price is about $180,000. But I think if for anyone who's looked at the 3D printing market, you can certainly see over time that the technology becomes less and less expensive and more accessible to the everyday person, whether it's through a service bureau or machines that were big that are becoming smaller and more of a prosumer level machine. We certainly expect that those same sort of things are going to happen with our machine. So we again, without giving out too much away, I would say just stay tuned, and I think that things in that direction will improve soon.
Right. So I have a question. So if you were to kind of explain this to a child or someone, how does 3D printing actually work? So what are the things that go into this thing, into the process, and what materials do you need to buy to get kind of the model going? Is it first being printed, the base model, and then the colors are applied, or is everything happening simultaneously? How does it work?
So I think the best way to think about our machine is two different ways. One is if you think about an M&M candy, right? If you cut the M&M candy in half, you'll see that there's chocolate that builds the shape of the candy itself, and then there's that colorful outer shell. That's kind of a good analogy for how our machine prints, in that if you take one of our full color models and you were to cut it in half, you would see that the inside of that model is really pretty much just white and clear material, and the color is just happening on that outside edge, right? But for a analogy of kind of how 3D printing works in total is, if you look at an object, let's say you've got a model that you've designed, and you think about taking that model and slicing it into a series of really thin layers, and then you took those layers, and each one of those was a separate picture that you fed to your desktop inkjet printer, and each layer was a separate sheet of paper. And as you stack those sheets up, you would get that full object. That's really a simplified view of how our printer works.
Okay, I got it. Thanks. So another question, I guess a lot of people in our community have is, some of the things that you showed, they are very large in size. So my question is, how big can you go in terms of your printing capabilities? Can you build something, let's say, as large as a car, or do you still need to print something that's, I don't know, maybe 10 inches long or something? Is there a limit to how far you can go with that?
Well, when it comes to the printing envelope of the machine, you can do 20 by 20 and 12 inches. That's the maximum printing envelope. Obviously, when it comes to parts, and I guess the best way to have a good industrial approach to printing large parts is always to segment everything into make different components and then make an assembly based on that. The cost is definitely higher compared to other products, but it really depends on the application as well. So I think
the largest, what was the size of the Nemesis model that we did for a dope poke?
Yeah, so that one, for example, that was a single piece. Actually, it was two pieces. So the body was actually, the main piece. It was 19 inches tall. That one, it was more to prove that the machine is a reliable product. That was an entire week of printing. I mean, the machine was completely nonstop. I just had to, just check a couple of things, and it was just like preventive maintenance, make sure that the machine was working. But I never had to really intervene too much into the printing process. So the machine started the job, and I just had to supervise it a little bit. So the machine was, that was more like a statement that we can do this part, this really big part, because no other machine can do that. Most of the times, our competitors have half of the capacity of this machine. So in this case, this very special product was possible because the machine had a really big envelope. like a big printing area.
I mean, it makes sense, right? Because the majority of these, when you go into like 3D modeling or building some kind of like a character or something, you still want to kind of build separate parts of it, right? And most of those figurines, they're kind of segmented into like separate elements that are then assembled and kind of they go from there. So it's not something that majority of 3D artists should be surprised, right? They kind of know how it works, right?
Yeah. Plus we were, in that case, Jaime was able to hollow out the model, and we put LED lights inside of it to get it to glow from the inside. There's some really
nice
cool things that you can do. Plus you can do weight saving and things like that by segmenting it into different pieces and doing it as an assembly. We've also done some really large like aerial photography pieces. We did a project for Autodesk where it was an island, a Fijian island, and that was a huge print that took up the whole.
It was 93 hours to print.
How many?
93.
Yeah, 93 hours to print. So we can do really, really long prints, and you can put them together to make really as big of a piece as you want. The limitation is just the what can you do in one single print.
Yeah, I think like this kind of nicely ties into the other question is how long does the actual printing take, right? Because if we think about somebody who wants to use this kind of tech, so like in my case, I would want to use it for some kind of like a mass production thing, or like even if it's like a small number of units, I still want to print as many of them as I can and then sell it to my, supporters or clients. So I'm wondering how much would it take to print like 10 figurines or something like that? How fast does it go?
Yeah, it's the machine itself. The carriage that has the print heads in it slides back and forth, so it kind of scans left to right, and then it goes front to back as well. So you get some real economies of scale by lining things up in that linear direction. So if you had, let's say you had one figure, and one 6-inch figure might take you, I don't know, 10 hours to print, let's say. If I add a second and a third one that are in that same linear path, it might, two additional prints might only increase the print time by 2 hours. So it really has to do, as far as like quoting a time, it has to do with how tall is the figure? Are we laying it down? What orientation is it in? How thick is it? Those kinds of things. But I think that's what we figured was that we could get 2 or 3 6-inch figures in probably about 14 hours.
So when you guys are working with customers, do you provide them with this kind of know-how and knowledge and optimization and kind of teach them how that works?
Well, basically, we definitely use software when it comes to prepare estimates for the customer. So we do have a piece of software, and we are able to lay out the part and make an estimate based on, because the problem is the thing with 3D printing most of the times is you don't start with a standard shape or with something that is always the same piece. I mean, or something that is reproducible. So when you have so much variation on geometry, so definitely software is what is going to help you out to establish how fast or how many pieces can you get into the same layout. So definitely it's the software when it comes to give an estimate on price and time to the customers.
So it's nice that you mentioned software. So let's talk about like what do you actually need to start the printing, right? So in terms of like like a texture set or like the geometry itself, what kind of files do you need? So how does this process work? Is there some kind of additional optimizations that need to be done? Because I know there are like even separate courses on some of the schools that we work with that help you basically build a character for 3D printing. And the process there is a bit different than when you want to build something just for your portfolio. So what do you need in terms of like files and all the other stuff from the artist in order to start printing?
Well, so the first thing is definitely the base mesh. The mesh file is the it's really important. I guess it goes the same when it comes to optimizing the models. Try to have clean topology is the best. Is always your friend when you're modeling. Also, in most of the cases, you can use symmetry, but obviously, when it comes to artistic job, um, a lot of the and also organic pieces, well, so symmetry is going to be always present. So it's always a good practice to have clean topology. Color-wise, so we do support vertex color, which means you add in ZBrush is known as polypaint, so you can paint directly into the vertices of your mesh. And also, we definitely recommend to use texture mapping because just like in the video game world, you can always optimize your mesh. You can get I mean, the number of faces and triangles, you can go to the bare minimum without losing the physical detail. And also, the color will be managed by the JPEG or BMP image. So because if you're working on vertex color, you need to subdivide the model several times in order to get high quality detail on color only. So it's better to optimize through to texturing. Yeah, go ahead.
You guys actually did a very interesting project with Adobe at Substance, right? So you published a number of projects from the Meet Math contest. So could you talk a little bit about that and how did you work on the? Are there some peculiarities of kind of making sure everything works with the stuff that was done in Substance Painter? And if you think that maybe down the line you will have some kind of collaborations with these software providers where it would be easier to kind of like export everything into a, like a template or something that would make the printing easier with your equipment.
Yeah, well, I mean, now that you mentioned that, so at the same time, I was at the very same time that we started the project with Adobe. So I've been also learning because I started, with 2D printing. I had no idea what 3D printing or 3D modeling was 2 years ago. So when we started working with Substance Painter, it was really nice to try to get this workflow where you will have your base mesh, and then you will create your texturing and also your displacement maps, but not only for rendering on a screen, but also you will use those same maps to project the detail on the mesh. So it has a couple of extra steps, but it really, I mean, it really speeds up the process. So you can always start with that basic mesh. And if you're really good at texturing and understanding how light works and projects, so you can get really, really nice displacement maps or normal maps, to add those physical details. And then you can project. So it's a really seamless way to work with as compared to pure sculpting. Pure sculpting, I guess the biggest disadvantage is if you make a major mistake or like a bigger mistake, you have to start all over again. Like it's really hard to modify your mesh once you have projected a high, a high quality detail on the surface. So texturing is definitely more forgiving when it comes to that.
Sorry, yeah, go ahead.
Oh, I was just going to say, I think it's really been interesting, though, that as we're talking to the ZBrush people, or we're talking to the folks from Adobe Substance, that a lot of this output to full color 3D is something that they're really just starting to give some consideration to. So as we're working with them and we're giving them feedback on, hey, this is how we're working, and these are the things that would be great to have. We're starting to see some additional tools that are being added to the software that can help prepare files for 3D printing. And as I think as full color 3D printing becomes more and more common, that the software will, the different software packages will continue to evolve so that they're helping that same process as well.
Yeah, totally. I think what you said makes like 100% sense, because basically what ZBrush is kind of a software for this kind of use, right? So if you want to build any kind of 3D character, especially like a figurine, you just gotta have those kind of default as a default, or maybe like as an additional setup in your software, just to make things easier. And I just wanted to touch like on a bit on the poor artists, because they had to learn so much to make sure that their content is optimized for games, because there's like a bunch of other stuff that you need to go through. But now they also need to learn like how to optimize their stuff for 3D printing. But it seems to me, at least like from my perspective, that it's not that much that they need to change in their flow, right, to make it work. It seems like all the optimizations and kind of like the work with textures is already something that they're doing with games, and this is just like a little bit of additional tweaking and steps required to make like a perfect 3D print.
Yeah, I think it's just a matter to get familiar with the 3D printing process. One trend that I've been definitely looking into a lot of modelers and artists is they're getting their own personal 3D printers, even if it's a cheap FDM 3D printer, which is the one with the filament. It's always good to get a little bit of practice on it, because you have to understand. Yeah, I guess that the only the part for example for a person who is a video game artist, they understand very well texturing. They understand very well how to manage poly count or triangles. But at the same time, you have to understand all the variables that 3D printing has. So it's always a good. I've been noticing that people are already getting into practicing and getting into 3D, by themselves, which is really nice.
And I got to tell you, for whatever effort it takes to learn that, to see the look on an artist's face when they're holding a full color 3D print of this thing that they had seen on the screen, and to hear them say, we heard this over and over again at the ZBrush Summit, saying, wow, I never thought I'd be holding this in my hand. It's really cool.
Yeah, I mean, I completely agree with you. I think that this kind of trend of getting yourself a 3D printer and starting to play with it like on your own is something very, it's something very classic for this kind of community, because 3D artist community, they love to tinker with new things. And if you look at it like historically, like tools like ZBrush, tools like Substance Painter, then kind of change the whole process, right? They kind of open up like new ways that people can be creative and build more stuff. And just 3D printing brings another dimension to that, right? So they just don't need to have this only on their screen, but they can actually print on like a physical object. And I know a lot of like sculptors from whom you featured like on your Instagram page, and it warms my heart to see that they're actually building something. They actually have the opportunity to have this in their hands, because their work is tremendous, and I think it makes sense to have it published and produced, and then maybe you can sell it eventually to go on an event or somewhere. So for me, it makes total sense. And even those like cheaper, smaller models of 3D printers that you mentioned, a lot of people actually used it for like commercial use, because maybe they couldn't get the accurate color, but they would just build print a 3D model, and then it would be like grayscale, and then people would buy it and then or use it and then color it themselves, just as they do it with like Warhammer models and stuff like that. So I see a lot of implementation there as well.
Absolutely.
So guys, we're almost like kind of nearing the episode. So I'm wondering if somebody is like interested in getting more into 3D printing and trying to understand how this thing works, where can they go? How can they contact you? maybe you have some resources or like tutorials or stuff like that where they can learn more and trying to understand the advantages of this tech and how they can kind of start working with it.
So Mimaki is we are a global company. So please check and see if you have a Mimaki dealer or distributor in your country. The Mimaki USA YouTube site has a couple of tutorials and webinars that Jaime and I have done, where I talk a very little bit and then Jaime shows all the magic that he knows. So we've done some with how to prepare files with Adobe Substance, things like that, and we'll certainly continue to do that throughout the year. Stay tuned to our Instagram page. You can see different projects that we're working on there. And if you have any questions, you're more than welcome, wherever you live, to reach out to Jaime or myself through social media or however else you'd like to.
And one last question. Do you guys work with any schools? Because I know a bunch of students would love to see their stuff printed out.
At the moment, we're working with Clemson University. So it's the Sonoco Packaging and Design Institute. That's so it's mainly for prototypes. We actually have a unit over there.
I think 2021 is going to be a year where you will see more Mimaki equipment out and around schools and things like that. As I said, stay tuned. We have some exciting stuff coming up.
All right. Well, thank you for the news. I think it was a very interesting episode. So guys, please check out the links in the description. We will try to add all the information there so you can go and check it out. And thank you guys for joining. It was very interesting.
Hey, thank you.
Thank you.
Thanks for enjoying another episode of the 80 Level Roundtable podcast. Check out upcoming episodes on the 80 Level website at 80.lv. Join our career site at 80.lv/RFP and share our podcast with friends and on your social networks.